Hi everyone, in this video I want to explain my current approach to context engineering or context management when building or architecting AI systems. So my entire context engineering approach is built around the idea of context engineering is the new memory management. Once I explain the analogy between computer systems and LLM systems, it will become obvious. So if we map the LLM systems and how they manage context to computer systems and how they manage memory, the analogy becomes clear. So context window is the RAM, any prompts or instructions is the stack, any external knowledge like RAG, DBs, etc. is the disk, and the retrieval is paging. And if we take a look at the context window, so the first thing that goes into the context window is the system instructions. So you describe what the agent is for and how to perform the necessary tasks to accomplish the goal. Then the conversation history, like if your agent is join-based, and any tool results or retrieved knowledge will be added to the context window at runtime, and any user input for the next runs will be added also to the context window. And any space left is the available space for subsequent runs. The thing about context is more context doesn't equal better results. If the quality of the context is noisy and not clear, it will confuse your agent and introduce issues in the results. And also, every token adds an additional cost for both performance and your final cost for how much you are paying for the tokens. That's why we have two calls and scales. So instead of including all the context at ahead of time, you instruct your agent to find any needed context at runtime using tools. And scales also is a form of tools that help steer the agent or find the correct ways to use those tools. So because you don't want to include all the instructions on how to use the tools ahead of time in your system prompt, because that will bloat your system prompts. And the second thing, if you have a lot of tools, it's better if you perform a selective step before your agent starts working. So you select only the tools you need and include some description in the context of your agent ahead of time. Then if the agent needs any additional instructions on how to use those tools to accomplish the goal, it will load a scale related to that, or just use the shell instead of creating specialized tools for any part of the agent's work. So the thing about context windows, you must manage them actively. So you don't want to be lazy in terms of how to manage your context windows, and that includes a few things you can do. Like in practice, it boils down to a few things you can do to optimize your context and deliver the best results. The first thing is filtering. When you want to include any information that's relevant to your agent, you need to find the best quality data that will be used by your agent, and not just be passive about what you include ahead of time in the context, because that's the fastest way to degrade your quality of the output. Then you have ranking. If you have any RAG pipeline, you need to first find all the relevant documents or chunks for the query. Then you assign a score for each of those chunks or documents, so you can rank them and exclude any chunks or documents that are less than your threshold. Ideally, something like 70%, or in decimal numbers, it will be 0.7, and above it will be good. And also try to limit the amount of chunks you include to your agents if they are not that relevant to your query. Then we have compression. Since we have limited context windows, most models have 200,000 to 1 million context windows, even though I think the models that have very large context windows are not that really great at delivering the best results. But compression plays a big role in terms of keeping your context window clean and only include the latest and relevant information in your context window. So you compact anything above a certain point in your conversation history, and you leave some of the recent terms to help the models stay on track. Then you have isolation. And that means like you keep the instructions and the user input and retrieve data logically separate. So your system instructions, for example, they don't have to include anything to related to the user input or any like retrieved data ahead of time, because like you can't anticipate really the user input. So you need to make your model resilient and like help the model like find any data or information it might need at one time. Then you have lifecycle management. This also includes compression and any techniques I may talk on some of them in the future videos that help like keep your context management approach intact and help your agents have quality context for your task. Also, if we go back and revisit our analogy between LLM systems and computer systems, bad context always gives us undefined behavior. The same thing as like when you have memory corruption issues in traditional computer systems, most likely you get undefined behaviors, which are like deliver unpredictable, inconsistent, and low quality outputs in case of LLMs. So you must avoid these failure modes at all cost. The first one is irrelevant context. So because this like distracts your model and dilutes the model attention to what's really important to the conversation, you need to make sure always the context you are including is relevant to the task. Then you have conflicting info. So like sometimes you have those instructions with capital case that say like to the model like don't do that or do this instead. Like sometimes you have contradictions. What I saw in different agentic systems, sometimes they include contradictions in the way they instruct the model, and that's like makes the model conflicted in terms of like how it should behave. So always make sure your system instructions you include in the context are like coherent and have like the same goal or align the agent to perform in a coherent way. The third failure mode is noisy context or redundant context, and that wastes capacity and leaves less room to what actually matters to the agent to perform the necessary steps to accomplish the goal. So you can like always do compaction, and when you create a model that summarizes the old terms, you must always make sure you instruct that model to understand first the requirements and the context of the goal before start summarizing, and you can perform like a sort of filter or remove anything that's not relevant to the context. And the last failure mode is missing information, and this is the issue that causes hallucinations and wrong assumptions by your model, and that's why we have in the first place we have RAG. So RAG helps like at one time load any necessary information from external sources to the model, so the model can easily find what it needs to accomplish the job and not just use its knowledge, because that will like cause hallucinations and assumptions that are wrong in your business case, your agent's like goal. So like you first, before like start doing any context management or context engineering, you need to ditch the old model, which is like just writing better prompts will yield good results. Because now, like if you go to business-oriented people on YouTube or something, and you find those people like to talk about this prompt will give you like the best business model for your business or the best strategy for SEO or something, and you find like it's just a prompt. It's not really a system. So the new model is building a system, because context is constructed, not written, and your system needs to have a pipeline that's like following these 5 steps. So the first step is planning. It needs to detect the intent and understand the constraints and the requirements of your desired goal. Then, like the system needs to retrieve any relevant or necessary data and allocate memory in the context window. Then you need to optimize and rank and remove any noisy results from your context before the model starts working. Then you assemble and validate the entire context, and you start generating your output. And that ensures that quality in, quality out, and you get the best results. Stay tuned for future videos, and I will explain some other concepts that help build the best efficient and high